Assalamu alaikum kids, this is Ayaz again. I'm with you for week 7 assignment, and as usual I'm going with grade 7 math, and it's lecture 1 of week 7 now, and the topic is factorization of quadratic expression. You can find this topic in your book 2 on page 101. And as usual, I'm going to have a little recap of the things which you have already studied. And what we have studied so far is that how to expand and simplify an algebraic expression. And I took one or two examples in front of you over here. The first one is a bunch of terms on the left side, and you expanded first, means multiplying 5 inside the bracket and 2 minus 2 inside the bracket, and then after that you simplified. And you guys know this one now. The simplification means adding or subtracting the like terms, and you got the final answer on the right side, 3x plus 11. So that's what you have done here is the expanding the left side, and then simplifying it, and you got the answer 3x plus 11. And I took another example in front of you over here. The two linear factors are here on the left side, x plus 4, x minus 1. Multiplying these two factors and then simplifying it, you got the answer x squared plus 3x minus 4. So these two examples of expansion and simplification, and hope you are pretty good with these two things now. And here is today's topic. And before we jump into today's topic, you should know what is factorization first, before we go into factorization of special algebraic expression called quadratic. First, let's see what is factorization. You're pretty much familiar with the factorization actually. Factorization of numbers. You remember? You factorize 6, like you do the LCM and HCF. You factorize 6, for example. So the factors of 6 are going to be 1 into 6 and 2 into 3 or 3 into 2. So 2 and 3 are 1 into 6. These two are basically the two pairs of factors of number 6. So that is the factorization of numbers. But we are interested now in factorization of an algebraic expression. So what is factorization? Basically, it is a process of expressing an algebraic expression as a product of two or more algebraic expressions. So you see, in factorization, what we do is we split it up. We break it up, an algebraic expression, into two or more algebraic expressions, such that the sign between all these child algebraic expressions are going to be multiplication. The sign between the algebraic expressions, which you have already got after breaking the main or original algebraic expression, is multiplication. That's the necessary thing. Only then those child algebraic expressions are going to be called as the factors of the original or the main algebraic expression. So that is the factorization. Okay, and that's the same example I had showed you before in expansion and simplification. Left side you expanded and then simplified, you got the answer on the right side over there. So basically that's what it is, that is expansion, right? Now if we write the same above equation, remember equation has an equal sign, this is going to be left and right side over there. So if we write the same equation in this form, what I did is just wrote that the right side on the left and the left side on the right side. So when two things are equal, so you could write either way is always correct. So now what is this? What we have done over here? You see, the left side is being broken into two linear factors, and the sign between these two linear factors is multiplication. So don't be surprised with where is the sign. I hope you already know this one. In algebra, when there is no sign between two numbers or two factors, the sign is going to be multiplication. It's understood. So x plus 4 and the bracket of x minus 1, there's no sign in between, so it means the sign is multiplication. So it means we have broken the left side algebraic expression into two linear factors, x plus 4 and x minus 1. Again, the sign must be multiplication between them. So that is the factorization. That is what we are looking for. And what does it mean? That the factorization is a reverse process of expansion, isn't it? It's in front of you here. In expansion, you have two child factors, you multiplied, simplified, you got the right side. Factorization, what you got as an answer in expansion, now that becomes a question now, and you split it up, that algebraic expression, into two child factors. So, and the sign between them is multiplication. So that is the factorization. So again, factorization is a reverse process of expansion. So that's not going to be a very new thing for you. And now today's topic, that how we are going to factorize a quadratic expression. So the first question comes, what is a quadratic expression? What kind of a special algebraic expression is going to be as quadratic? So here is the answer. That any algebraic expression of the form ax squared plus bx plus c, the red one, that is called as a quadratic algebraic expression. So how we are going to recognize algebraic expression as quadratic? So you see, in quadratic algebraic expression, there is going to be degree of the expression 2. Remember, what's the degree of expression? The highest power of the variable. Variable over here is x over here. So in quadratic algebraic expression, the highest power of the variable is going to be 2. That's must. And a, b, c are any numbers. Only restriction is on a, that a can't be 0. Because if a is 0, you place the a0 over there. So this 0 is going to be multiplied with x squared. So this first term, ax squared, is going to be vanished. So what is left going to be bx plus c. Bx plus c is not going to be a quadratic expression. In fact, that becomes a linear algebraic expression. So this condition must be there in a quadratic expression, that a can't be 0. Other than that, a, b, c could be any numbers, positive, negative, fractions, dot, everything is allowed. And just to remind you that a and b are the coefficients of a variable x. We have studied in grade 6. A and b are the coefficients of the variable, while c is a constant. This is a constant over here, means there is no variable involved in that terms. And just a reminder for you guys, in this algebraic expression there are 3 terms, remember? Ax squared is one term, bx is another term, c is another term. Okay, so now our task is how to factorize or break the quadratic expression into 2 or more linear factors, such that the sign between these 2 or more factors is multiplication. So in factorization of quadratic expression, we are going to break that algebraic expression, this red one, ax squared plus bx plus c, into two linear factors, and the sign between these two or more linear factors must be multiplication. So that is our task. And there's an example over here in front of you that we have already shown you that on the left side there's a quadratic algebraic expression, and we somehow we have broken that expression, and we got x plus 4 x minus 1, and the sign between them is multiplication. So that is just showed you that's we are gonna come up at the end. Now the question is how to do this. Okay, here is the very first thing we are going to do is we are going to multiply, always make it a habit that we are going to multiply the coefficient of x squared with this constant c, this a with c, always. Just make it a habit. I want you guys to make it a habit. Don't forget this one. So multiply, the first step is going to be multiplying the coefficient of x squared with c, and we will get the product AC. Of course, A and C are going to be two numbers, and when we are going to multiply A and C, two numbers, we are definitely going to get another number. So AC is going to be another number, basically nothing else. So now after doing this, multiplying A and C, we are going to look for such two numbers now that if we add these two numbers, we should get the coefficient b of x. This you could see this ax squared plus bx plus c in red on the top over here, this algebraic quadratic algebraic expression. So we are going to look for two such numbers. Basically, when we add these two numbers, we should get that b. What is b? That's the coefficient of x. And there is going to be another condition on these two numbers, that when we multiply the same two numbers, we should get the products AC. Don't be scared when we take the concrete example. So we will see how to what is the meaning of this one over here. And let's take an example here. I just took an quadratic algebraic expression, x squared plus 5x plus 6. Okay, so could you tell me what are a, b, c over here? Yes, the coefficient of x squared, in this case, in example over here, a is 1. When there is no coefficient beside x squared, means it's 1 there. B is 5, c is 6. Right now the coefficient of x is 5, but because it's plus 5, I didn't write the sign over there. But definitely you will see if the sign, for example, is minus 5x, so b is going to be minus 5. If c over here, if the plus 6, in place of plus 6, if it's minus 6, for example, so c is going to be minus 6. You are not going to never miss that sign. So in this example, ABC is 1, 5 and 6. So remember I told you what we have to do is we have to multiply the coefficient of x squared with the constant c. So the AC is going to be 1 into 6, which is 6 now. So the first thing we got is the product AC, which is 6. Definitely we are going to, so do you remember now that we are looking for such two numbers. If we multiply if we add these two numbers, we should get the coefficient b of x, and if we multiply the same two numbers, we should get AC. That is the special wanted pair of numbers, that if it has to satisfy these two conditions. That is in fact the hardest part of the factorization of a quadratic expression. That's the hardest part. Once you somehow figure it out, this pair of numbers, it's you have done almost like 50% of the work. So let's go back to the same example. We have already multiplied AC and we got 6 over here. So unfortunately there isn't any rule or formula built in. I mean that you just somehow use that one and you come up with these two wanted numbers. Now, but definitely there is ways to do it. One way to look for these two numbers is look for all possible factors of AC. Like in our example, AC is 6, right? Remember? So, and I hope all of you know that how to factorize the number. Like 6, like, even I told you like the same example before, that factorizing 6, for example, 1 into 6, 2 into 3. Don't write it down 3 into 2. 2 into 3 and 3 into 2 is the same thing. Or 1 into 6, 6 into 1 is the same thing. So 6 has basically two pairs of factors. 1 and 6, that is the one pair. When you multiply these two factors, 1 and 6, you got the 6. Or 2 and 3. These two, this pair, 2 and 3, is also two factors of 6. When you multiply 2 and 3, you got the 6 there. So these are basically two possible pairs of factors of 6. There isn't any other factors you can find out. Again, as I told you, don't write it down 3 into 2. 2 into 3 or 3 into 2 is the same thing. So we are going to look for the factors of the product AC. Okay. So here it is. Let's take the first pair, 1 and 6. And we apply those two conditions on this pair. If it satisfies those two conditions, then that is the lucky one, lucky pair that we are looking for. Okay, multiplying 1 and 6. Remember what was the condition over there? That these two numbers, when they multiplied with each other, it must give us the product AC, which is 6. So 1 into 6 is equal to 6. Okay, first condition is satisfied. The second condition was that if we add these two numbers, same two numbers, we should get the coefficient B of x. So 1 plus 6 is equal to 7. But in our example, the coefficient B is 5. So 1 and 6 pair, though it satisfies the one of the condition, first condition, the second condition is not satisfied. We are not getting 5 here. So you might say, okay, take 6 minus 1. If you take 6 minus 1, that works. It gives you 5. But when you multiplied 1 with minus 6, you are going to get minus 6. So if you are fixing the second condition as 6 minus 1 is equal to 5, you are losing the first condition. Then it gives you minus 6. Okay, let's go with the second pair now, 2 and 3. So multiplying 2 and 3, it gives you 6, which we are looking for. First condition is true. Second condition, adding the same two numbers, we are getting 5. So the second pair, that's what we're looking for. The second pair satisfies both the conditions. So 2 and 3 is basically the most wanted pair. It's the most wanted pair which we are looking for. And remember, when you have many factors, pair of factors of a number, only one of them is going to satisfy these two conditions, only one pair. So now let's start factorizing this algebraic expression which I took as an example, x squared plus 5x plus 6. So in this method, what we're gonna do is we are going to split the middle term. You see the middle term here, always in an quadratic algebraic expression, the middle term is going to be bx. So we are going to split the middle term. You will see how. So as I told you, the hardest part is to look for that pair of numbers. That pair, the most wanted pair. We've already done that one. So here it is. I just broke this 5x as 3x plus 2x. Look at the sign, equal sign there. The first step is 100% equal to the second step. As I should say, second step is 100% equal to the first step. Because if you add 3x plus 2x is what? Is 5x. Remember, the like terms are added. So in the coefficients are added, 3 plus 2, 5, to 5x. So 3x plus 2x is the same as 5x. Just only another shape or form of the 5x. So we have split it 5x into 3x plus 2x. Now remember, whatever the pair you have decided, that is going to be written over here. Nothing else, along with the signs also. What we have found was the 3 and 2, plus 3 and plus 2. The same signs are written over here. 3x and plus 2x. And now this one, this step I wrote it over here just for explanation. You will see when you're pretty good with the factorization of quadratic expression, you are not going to write this third step. You will be pretty good, and you will just right away in your mind you figure it out and do the third step. Just to show you what I'm going to do now, I wrote x squared in this form, x into x. You have already know this one, that x into x becomes x squared. When x is multiplied with the x, see the dot over there, it's multiplication. So you got x squared. And here in the last one, plus 6, 6 is being split into 3 into 2. Of course, 6 is 3 into 2. Okay, so what I'm planning to do here is, you will see now here what I did. Could you figure it out? Okay, a little bit, might be a little bit new thing for you here. Is what I did here is I took the common things out. So what is common now? Common means, for example, in this equation, in this third step, you see first two terms, x into x, this is one term, plus 3x, the second term. So first and second term, you could see in both these two terms, x is there. See the green one, x, and x is also here. So common, remember? Common means that like it's there, in both the terms it's there. So I took the common x out. So when I took the common term x out, so in the first term, x into x, what remained here is the 1x plus. In the second term, when the x, the green one, goes out, what remains over here is just 3, isn't it? Okay. Now the third and fourth term. In third and fourth term, you could see here something is also common, which is present in these two terms, third and fourth term. In third term, you see the 2, the green one. In the fourth term, again there is 2 present over there. Yes. So it means I can take 2 as common. So when I took it out, inside the bracket, what left is, in the third term, when I take the 2 out, what remained is just x And then in the fourth term, when I took 2 out, what remained over here is just 3. Okay. And after this, now in the step above, basically, again something common. Could you figure it out? Yes, the red one. X plus 3 is present in the first term, and x plus 3 is present in the second term over there, isn't it? So now I'm taking x plus 3 common. So when I took the x plus 3 common, what remained inside is, from the first term, just the x remains there, the green one. And in the second term, when x plus 3 goes out, what remained is 2, the green 2. So that's we are at the end. You see, these two factors, x plus 3 and x plus 2, and the sign between these two factors, the red and green, there's no sign between the brackets, and the no sign means there is multiplication in algebra. So we have splitted the quadratic algebraic expression x squared plus 5x plus 6 into two linear factors, x plus 3 and x plus 2. Remember, when you reach the final step, the sign between the linear factors must be multiplication. If there is some kind of sign plus minus there, it means that is not the end of the question. You haven't factorized that algebraic expression yet. There must be multiplication sign. And we do some more examples, and you see that get familiar with the things. So let's see what comes next. Now I took, as usual, practice now, and this practice now you can find in your book, book 2, page number 107. There's just a practice now. There's no number practice now 1 and 2. This is just practice now over there, 107 page. It has 3 or 4 parts over there. I took the first part over here, x squared plus 6x plus 5. Don't be confused that we have already done that one. What we took the example before was x squared plus 5x plus 6. This is 6x plus 5. Okay, remember the very first thing I recommended is we are going to multiply the coefficient of x squared with the constant c. Here the coefficient of x squared is 1 and the c is 5 plus 5. I multiplied these two and I got the 5. Now our task is that we are going to look for all possible factors of 5. 5 is the product AC. Okay, so you could scratch your head and you come up things. What I got is 5 can be only splitted into one pair. 1 into 5 is equal to 5. Other than this, you are not going to find any other pair of factors of 5, because 5 is a prime number, remember? Anyway, so it means the only possible factors of 5 is 1 into 5. So let's see 5 works for us or not. This pair 1 and 5 works for us or not. Yes, it does. The first condition, we multiplied 1 and 5, we got the answer 5, which we are looking for. That was the first condition, remember? And the second condition is when you add these same two numbers, we should get the coefficient b, which is 6. The question is in front of you, 6x. So the coefficient b is the coefficient of x is 6, b is 6. So both two conditions are satisfied. So it means 1 and 5 is the pair what we are looking for. So let's start factorizing now. So here is the equation, x squared plus 6x plus 5, and the second step is, remember, we are going to break the middle term 6x into two terms. And since I told you, once you found the wanted pair. So it's almost half of the work is already done. Just now mathematically playing with it. So 6 can be written as 1 plus 5. Yes. So here you won't see the coefficient of x as 1. It's understood. 1 is there. So, and you see x plus 5x is what? Is 6x. So there's nothing wrong to write it down the equal sign here. Both these two steps are 100% equal. So we split it up 6x into x plus 5x. Okay. It means that this steps comes over here. As I told you, in actually when we're going to factorize, we are not going to write this step. Just for the explanation, is because it's a new topic for you. I'm just putting it in front of you now. So I split it up x squared as x into x, and the 5 could be written as 1 into 5. Just show you the concept of the common actually. So here it is. So in the first two terms, x into x plus x, what is common over here? What is present in both these two terms? X. So just the x, I took it out. So what remained is, in the first term, when 1x goes out, 1x remains here. And in the second term, when 1x goes out, what remained over here is 1. And the third and fourth terms, you could see the common is 5 now. 5 is present in these two terms. So I took the 5 as common. So what remained is, in the third term, is basically just x, because 5 goes out. And in this fourth term, when 5 goes out, what remained is 1. And you could see the plus 5. We took plus 5 common. And in the final step, because x plus 1 now is common in these two terms, I took x plus 1 common now, this whole term. And what remained is, when x plus 1 goes out, remained here is x. And the second term, when x plus 1 goes out as a common, just 5 remains over there. And you see, these are the two factors. The sign between them is the multiplication. So we have broken this quadratic algebraic expression into two linear factors, and that is the factorization of this algebraic expression. Okay, now I'm taking the second part of the same practice now. X squared minus 6x plus 5. So again, don't say, sir, what's this? The same thing. Now it's not the same thing. In the previous one, we have plus 6x. Now we have minus 6x. So this is a different algebraic expression. The purpose over here is to show you how we're going to manipulate the signs also here. Yes. So the first step again is we are going to multiply the coefficient of x squared with the constant c. So and a, so coefficient of x squared means a is basically 1 and c is plus 5. So multiplying 1 and 5, we got 5. Okay. So we are going to look for the factors as usual of this 5, this a product AC. And luckily 5 just only have one pair of factors, 1 and 5. So, and this pair now, let's see it's going to work for us or not. So 5 is equal to 1 into 5. That's the first condition. So we are getting 5. Fine. Remember, first condition was this pair of numbers, when they are multiplied, it should give us the product AC, which is 5. Second condition, when we add these two numbers, we should get the coefficient B of x. Remember now, the coefficient of x is basically minus 6, not 6. Yes, minus 6, that is B. So 1 plus 6, 1 plus 5 is equal to 6. But we need minus 6. Okay. So this 1 and 5 so far is giving us the tough time. Okay. Let's play with it. Here it is. Okay. So if I take rather than 1 and 5, minus 1 and minus 5, so multiplying minus 1 and minus 5, we will get 5. I hope you remember all those rules which we studied in grade 6, multiplication rules of the signs. So here you could see minus, multiply with minus, it gives you plus. So 1 into 5 is 5, so we got the 5. Okay, first condition is true. The second condition now, remember, when we decide the two numbers, the same two numbers must be multiplied to get the product AC. The same two numbers must be added to get the coefficient B of x. So here it is, minus 1 plus minus 5. Again, remember the rules of adding the signs also. Rule was, when the signs are same, both are minus, negative, so the numbers are going to be added. 1 and 5 are added, it gives you 6, and if the signs are same, the same sign comes as the sign of the answer. So you got minus 6. So it means the wanted pair is minus 1 and minus 5, not 1 and 5. So 50% of the work is done. So here is the factorization now. Here's the one. So I just so this pair we just broke the middle term, minus 6x. So as I said, there is no hard or tough time now onward. Just simply write it down with the pair we have already decided. So minus x and minus. This time I just wrote it down in front of you, even minus 1x, you see, just to show you things. Otherwise you know this one, there is no need to write 1 beside x. The coefficient 1 is understood, is there. So minus x and minus 5x, and you know when minus x and minus 5x are added, what you will get is minus 6. Yes, minus 6. So, and here is this step which I told you. Normally in actual practice we're not going to write it down, this one, but just in front of you I broke it down, x squared as x into x and 5 as 1 into 5. Okay, to just show you when we are taking the common things. So in the first two terms x is common, take the x out, so I got here x and minus 1. Okay, in the third and fourth terms now 5 is common. Okay, 5 is common now, but I took minus 5 out. So I took minus 5 out now. So when in the third term, when you take minus 5 out, what remained inside is x, and you see the minus then sign over there. At this stage you can think of as it is, when you take minus out, so this plus is going to be minus now, because if you do a little reverse process here, if you just show you, don't be confused here. When you multiply this minus back, basically means when you expand this one, so this minus sign when multiplied with the minus sign inside, you will get back what? Plus sign again. Remember, from the very top we are putting the equal sign. This means all the steps are basically 100% equal. Just we are playing, we are changing their shapes. Otherwise all these steps are 100% equal. So when this minus sign is multiplied inside the minus, it becomes plus, the same thing. So I took minus 5 out. So you can remember now this thing, when you take minus sign out, so inside sign is going to be reversed. If in place of plus there is a minus sign, so when you take minus 5 out, so this minus sign is going to be plus. In this case the plus sign, it becomes minus inside. So, and finally we see x minus 1 is common in both the terms, so what remains inside is x, and in the second term when x minus 1 goes out, just 5 remains inside. So that is the final touch, that we have split it, the original quadratic expression x squared minus 6x plus 5 into two linear factors, x minus 1 and x minus 5. Just keep on reminding you, the sign between these two factors is multiplication. That's must. otherwise you haven't done the final factorization. Okay, and there is I just skipped the C part now. Basically I took the D part now of the same practice now, and this is x squared minus 8x plus 12. As usual, as I recommended, that we are going to multiply the coefficient of x squared with the constant c. So a is here 1 and c is 12, so we got 12. So we are going to look for such two numbers, these two factors of 12. When those two factors are multiplied, we should get this product AC, and when we add the same two numbers, we should get the coefficient B of x, which in this case is minus 8. Remember, don't go for 8. Minus 8 is B in our example now. Here are the all possible factors of 12. In the first, 1 into 12, 2 into 6, 3 into 4. What I know is there are no other factors of 12. Again, don't say 4 into 3 is a factor also, 6 into 2 is a factor, 12 into 1. 4 into 3 is the same, 6 into 2 is the same. So these are three pairs of numbers which are the factors of 12. These are the only possible factors. Now, the question is, which pair is going to work for us? Means, which pair is going to satisfy those two conditions, which makes that pair the most wanted. So just a little logically a rough idea which will work for us here is, you have to keep in mind, because multiplying all these three pairs, it gives us the 12, isn't it? Now the task remains whether adding these two numbers, does it give us the minus 8 or not. So so to figure it out, to go to the to our answer, we are going to play with like this, that just a little idea that 12 plus 1 gives us 13. What we are looking for is minus 8. Okay, 12 minus 1 is 11. We're looking for minus 8. So this 1 and 12 pair goes out of the contest. Okay, so 3 plus 4, 7. We are looking for minus 8. Or 3 minus 4 or 4 minus 3, it gives you 1 or minus 1. This pair also goes out. What remained is 2 and 6. 2 and 6, when it added 2 plus 6, it gives us 8. Still we are looking for minus 8. It means that we can play with the signs of this pair 2 and 6 to come up with what we require. Okay, let's try. So what I just told you, that if you multiply 2 and 6, you got 12. Okay, fine. First condition is true. 2 plus 6 is 8, but what we are looking for is minus 8. So still a little bit little closer, but not still got the answer. Here is the one. Okay, if we take minus 2 and minus 6, when they're multiplied, it will give us 12. Yes, that's what we're looking for, the product AC. Plus 12, yes, fine. Now minus 6 and minus 2, when they're added, you got minus 8. So it means this is the required pair what we are looking for, minus 2 and minus 6, not 2 and simple 2 and 6. So let's and factorize it now. Here is the first step. We will break this middle term, minus 8x is a minus 2x minus 6x. And again, I keep on reminding you that adding the like terms, minus 2x minus 6x is what? Minus 8x is the same thing. So here it is, this step. I just show you how to take the commons, and here it is. In the first two terms, x is common, so I took it out. What remains is x minus 2. And the second, third and fourth term, I just split it up 12 as 2 into 6. To show you 6 is present in third and fourth term. So when you take 6 out, I took minus 6 out as a common. So in the third term, what remained is x. And in the fourth term, when I took 6 out, 2 remains there. And as I told you, when you take minus out, the sign here, if it's plus, it will become minus. If it is minus, it will become plus here. And here now, the final step, in x minus 2 is common in both the terms. So I took my x minus 2 as a common now. What remained is x minus 6. In the first term, when you take x minus 2, what remains is x. And in the second term, when you take x minus 2 out, what remained is minus 6. So we have factorized this quadratic algebraic expression, x minus 2 and x minus 6. These are two linear factors. Okay, champs, it's your turn now. As usual, I used to say that I want to know that how much you got, which I already put some effort for you guys. So as I recommended, take a short break, pause your video for a while, go to your book 2, and on page 108 you will find the solved example 6. But here now, just take an example for the question from there. There are 3 or 4 parts of that example. Just take one part. And don't go for the way what he has done over there. The book author of the book had done that example. So that might be confusing for you. Go for the same way which I had followed. So take a question from there and try to solve it the way, as I said, I did. So take your time here. And solve 3 or 4 parts of that one, and then come back waiting for you. And as I used to say, I hope that by doing that, solving that example, you got a little bit better understanding now of the topic. And here is your first assignment of this first lecture of week 7, and here it is. So exercise 3b, and the question 1, and its parts A, B, C. Pretty much the same way which I have explained to you already. Inshallah, it will be quite easy for you, these 3 parts, because there's a basic level of that exercise. And as usual, I'm going to wait. And before I say goodbye to you guys, here is my email address. You could see on the screen. Write it down. Basically, why I'm giving you this email address is because the kids are kept on saying how we can send you these homeworks or the queries or these responses. So either way, you can upload it on your AppSec system, or you can email to me these files, images, whatever you have, attach those one. But remember, you gotta first create your own email address, email account. I think it will be pretty easier. Go to your Google or whatever you want to have it, Gmail. So there's going to be option for sign up things, I think. Sign up, and then it just takes you step by step. Enter your name, father name, and all kind of stuff, and then you have to choose an email address, whatever you want. And remember, when you take any email address that you will choose a name, it might not give you that one, because that name might have been taken by somebody else, so it's not available. So then you keep on changing your email address. It might suggest you also that you can take this. So it's not going to be, for example, you want to have some kind of funny or some kind of lucky email name. So it might not be available. So you can have any other email name, and once you're done with all this process, it means now you have the email account. So first you have to create an email account, then definitely you are going to be able to send me the mails. So I will wait for your responses. So that's it for today. Goodbye, take care, thank you.